Good morning. Oh, good morning. I'm Kirsten Baumgart Turner, and I'm guest host today for Hawaii, the State of Clean Energy at ThinkTechHawaii.com, streaming live educational and civic engagement on the internet, Olelo and Oceanic Channel 16. Our guest today is Dr. Reza Ghorbani, Director of the Renewable Energy Design Laboratory, REDLab, at the University of Hawaii at Manoa. He's also Associate Professor in the Department of Mechanical Engineering. Dr. Ghorbani received his undergraduate and graduate degrees from the Department of Aerospace Engineering at Sharif University of Technology in Tehran, Iran, and his PhD in Mechanical Engineering from the University of Manitoba in Canada. His current research interests include power systems and smart grid technologies, as well as the design of hybrid power systems, energy management methodologies, and large-scale renewable power integration to the grid. This morning, before we speak with Dr. Reza, if I may,
yeah, sure.
We're going to have our megawatts moments from Jim Pastor at Hawaii Energy. Thank you.
Hi, Kirsten. Thank you for inviting us to do the megawatt moment. I'm here to remind folks about Hawaii Energy. And Hawaii Energy, we are ratepayer-funded entity that provides rebates and incentives, education for electrical consumers. So basically, if you have a HECO account, and you guys, and the person does energy efficiency, you may qualify for rebates. Some of the rebates we have available are for HVAC or air conditioning, lighting, also for basically what I ask customers is anything that is going to reduce your electrical consumption, give us a call, see if it qualifies, and if it qualifies, then we might be able to give you a rebate. The rebates typically they reduce the cost of the project by 10 to 25% or sometimes higher. But more importantly, when you work with us, one of the things that we can do for the customer is to make sure that the equipment is of good quality. We have standards. In order for equipment to qualify for rebates, they gotta meet certain standards for safety. They gotta be UL listed, or also they need to be tested for quality, be listed in websites such as Energy Star, Design Lighting Consortiums, or other websites.
Do you do the testing, or is it standard testing?
It's a standard testing that what happens is the quality manufacturers, they want their products to be differentiated from other products in the market. So they go through the extra expense and extra effort to have their products tested and qualified by Energy Star, Design Lighting Consortiums, or Lighting Facts, and also to be tested by underwriters' laboratories for insurance. So you can keep your insurance policy current or active. What we're seeing, I think what's important to mention is that I've been with the program for about a year, and one of the things that I'm seeing is that there's a lot of lighting products in the market, and sometimes the customer has so many choices, but they don't know which choices is a good choice for their building, and they're buying inferior products that, although they might be cheaper to use, they are not meeting safety standards, and they could be potentially dangerous. One of the things that we do at Hawaii Energy is if we have a customer that has a potential project, they can tell us what the product is, and we can check to see that the product meets those safety and performance standards.
And some of those performance standards might be that although they're more expensive, they last a longer period of time, and that's something that consumers ought to be looking at, right?
Absolutely, yes, you're absolutely right. One of the things is that we like to say is we want people to go for value, not cheap. So.
Terrific.
So anyway, one of the things is if somebody in the public has a project or they want to find out about Hawaii Energy and the incentives and rebates we provide, to please give us a call at 808-839-8880. Again, the number is 808-839-8880, or you can go to our website at www.hawaiienergy.com. So we'll be more than happy to help you.
Thank you. This is a great public service, and I hope people avail it. So we appreciate you always coming on Megawatt Moment.
Thank you. Thank you for
Jim.
inviting us.
Well, let's turn to Reza. A quick question before we go to a break. What brought you to Hawaii via Tehran and Manitoba, Canada?
Well, that's a great question. I was, after I did my master, I went for my PhD in Canada, perhaps. I finished my PhD and I had two options. One, I had a fellowship that I can go anywhere in the world. The government of Canada would pay.
Wonderful.
I had a fellowship from Japan that I had to go to a Japanese university. So, and at the same time, I've got the offer from University of Hawaii. And I said, okay, which one should I choose? And Hawaii was very, very tempting, so I ended up Hawaii.
It's a no-brainer usually.
Yes.
Well, when we come back from break, I'm going to ask you more about that decision.
Okay.
We'll be right back with Dr. Reza Ghorbani. Mahalo.
Aloha, my name is Jim Sean, and I'm host of a show called Education Movers, Shakers, and Reformers. Each week, live streaming at noon on ThinkTech Hawaii, we interview people who have special insights into education, from early education through K-12, all the way through higher education and beyond. Both public and private are areas we're interested in. We dig deeper. We try to find out what it's really like to be involved in making change, advocating for it, how you reform, what people's philosophies are in reforming it. As I said, we're live streaming every Wednesday at noon on ThinkTech Hawaii. And later on, you can find these interviews on YouTube and on the Hawaii Educational Policy Center website. We hope you join us as many times as possible. Aloha.
Aloha! How you doing? It's me, Angus McTech, wishing you to welcome and join us to see us on Hibachi Talk on ThinkTech Hawaii. Join my co-hosts, Gordo the Tech Czar and Andrew the Security Guy, every Friday from 1300 to 1345. We look forward to seeing you. We'll talk tech and we'll have some wee bit of fun. And remember, let your wing gang free wherever you be. Aloha!
Aloha, I'm Carlos Juarez, host of Global Connections, and I want to invite you to come join us. We cover a range of global issues. We bring a lot of expert opinion, a lot of issues, whether they're contemporary events happening in the world or maybe looking at things from a more historical perspective. Global issues, very important for us to understand in this globally interconnected world. Join us here on Global Connections.
Hi, we're back with Dr. Reza Ghorbani. He's the director of the REDLab, Renewable Energy Design Lab. And I understand that it's known as providing research at the intersection of power systems, intelligent systems, and communication.
Right.
What is that exactly?
Oh, that's a smart grid. So in a traditional power systems, we have generations, and generation units actually generate power, and that power is transferred via transmission lines to substations. And then that's from a substation, that power is redistributed in a couple of feeders, and then after those feeders also are redistributed to the customers. So basically, what the traditional power system needs to know is to make sure that they can take care of the health of substations, health of the equipments, the safety of the whole network, and the generation. And they have to make sure that they can ramp up and ramp down and catch up with all variations in the grid.
So that's basically a software program.
The generation units are real mechanical, electromechanical devices like generators, steam turbines,
right,
diesel turbines, and the control system that take care of the generation units are local, but they receive a command from an operation room let's say HECO's operation room is in Honolulu, and they send the command to generation and dispatch them and say, okay, which generation generates what. So we have a sort of communication inside the traditional power systems. We have a control system that tries to control everything, but when you move toward more renewable energy into the grid, and when the renewables are so distributed, like lots of thousands of rooftop PVs, then the electric utility doesn't have visibility of what's going on in that part of the generation. So they can have, in terms of Oahu, let's say, they might have up to more than 200 megawatts of solar PV that they don't actually measure themselves, and they don't see what's going on. They have the aggregate load of the whole island. They have no visibility of each devices or each after the substation, they don't have much visibility.
So when you say integration of the systems with communications, is that where software
then
comes
the
in
software
to be able
comes in,
to?
and then, so let's say when this renewable energy integration increases, somebody needs to manage the grid. Okay, for HECO, if we want to go toward 100% renewables, even 50% renewables, is extremely difficult and expensive to deal with it if there is no way of understanding what's going on at the load side, what's going on at all of these distributed PVs.
The load side being the power coming in.
The load side is the residential customers, homes, businesses, hotels, and whoever that takes the power from the utility.
Right.
So, and one way of dealing with this intermittency is variability, huge variability in the grid, is having a demand response, having the load, having some flexibility, and they actually react to the price of the current.
And I just want to clarify for our audience, the demand response is on the customer end.
Yes, it's at the customer end. And so then you have to have a very good prediction system to understand what's going on in the next 4 seconds, next 10 minutes, next 15 minutes, next 24 hours. You need to have control, decentralized control on each generation, like each rooftop PV, each significant loads or aggregate of those loads together. So for that, you need a communication. Right. You need a communication. And that communication is there, like internet is a good way of communication. The cellular network is a good way of communication, but the utilities, normally they don't use them. They have their own network because of the security. And also intelligence system is when you have all of these, when you want to predict all this variability, you have to add intelligence to the system, to the power system. And that intelligence can be distributed everywhere in the grid. Let's say.
Now, is that intelligence based on modeling, or is it actual real-time data that's coming in?
Intelligence system, that's a very good question, actually. It goes a little bit technical. So you, let's say you are an intelligence system as a human, right? When you grow up, you learn how everything works. You learn how to walk. So you have data, you have memory, and that data is in your memory. And also instantaneously, you have to react to whatever happens around you, right? The lights goes on, off, the cars coming. So, and then you have to use your memory, what you learn, and you have to react to them. So a combination of these with a swift response needs a cognitive system. And that cognitive system, which uses the historical data and real-time data, is an intelligence system.
So it's very similar to our cell phones that learn the different addresses that we use or internet sites, and they're cached and they come up very quickly because it's learned what we do. Is that similar?
Oh, kind of similar, but even more intelligent.
Okay.
Even more intelligent because it tries to maximize your own benefit. It tries to make sure you save more money. If you have a demand response in your home or apartment, you try to reduce your electricity bill. And consider that in the future, the electricity comes when we have wind, when we have solar PV, when we have the generation in place. Or we have to use battery storage, which is expensive.
So this smart technology is actually going to tell me, the customer, not necessarily me personally, but to my system in the house and the system that connects with the utility, where to draw the power from, and the demand response side is a communication with the customer to be able to actually manage that?
It's close. So the demand response is part of the smart grid. The demand response is one piece of the solution.
Okay.
Demand response communicate with an aggregator, with a retailer, with somebody that interacts with the utility. Okay, and that aggregator, for example, talks to 1,000 or 10,000 customers at the same time, and try to manage your load. Let's say turn on and off your water heater at this time. Then you have if you want to take a shower at 9 p.m., don't worry about it. So the intelligent system makes sure that you are flexible enough and you save lots of money, okay? Intelligent systems tries to maximize the benefit for you. And also that means that, well, when the power goes up and down, when the generation goes up and down, you respond to that as a price, because when there's low energy available, less energy available, the electricity becomes expensive. When it's more available, there's lots of PV panels, lots of good sunny day. You have lots of sun, so let's use it that time. So you address the benefit of the system, and also you maximize your own benefit.
So the systems that you're developing don't exist right now?
Well, the smart grid is a broad field that lots of researchers in the world are working, but still it's very, very interesting, and there are lots of questions to be remain. So we are trying, in my lab, to address part of those questions, which is more specific to island networks, to isolated network that they don't have interconnected lines. And so
if we can solve this in Hawaii on an island network, it will then help other places that add the complexity of underlying.
Exactly, because the solution, everybody, let's say if you go to the conferences, they talk about the traditional way of controlling the system is top-down. So let's say a utility measures your heart rate, and from the heart rate tries to control all of your body. But what the bottom-up control is, we have sensors in your eyes, in your brains, in your tongue, in your ear, and we have sensors everywhere and coordinate them together. Okay, that's a smart grid. So when you have a scalable solution, which is bottom-up, then you can copy and paste it anywhere in the power system. Well, you have to look at their model, you have to custom make it, you have to do lots of mathematical modeling and understanding of the system and its variabilities, the inputs, outputs, and then you custom make it for them.
And the custom product that you're making is both a mechanical product and a software product?
What we are doing in my lab, we have a device. We developed a device that connects your home. It has a current transducer. It measures your power, okay, at your home or at your building. And also your power box of the home, you have a power box that has circuit breakers that turns on and off your devices, or communicate with the plugs, the smart plugs that the companies have. And then it sends your data to a server. Okay, that server, let's say 1,000 customers send the same data to that server at the same time. So what we have this this measurement system that sends your data every 1 second to a server. Then you can put your algorithm, your optimization algorithm as an app. You can buy it from any company, and that company on the cloud can do optimization for you to maximize your benefits, to minimize your electricity cost by 10. Let's say it's a timer that turns on and off your water heater. It's Wi-Fi communication. Our system is working via Wi-Fi, so you can communicate with your AC or other devices that you have in your home in order to manage it based on the price signal.
Would I be able to do that from anywhere, or do I have to be in my home?
Since the data goes to a server, you need to have the login. If you want to look at your data, you need to have a login and password to make sure that only you can see your own data. So yes, definitely you can see your own usage, and I have it. I have it in my home, and I see it in a server. So
I see how this would benefit the customer. Can you explain more how it benefits the utility?
So assume that, so we have an optimization algorithm that we are working on my project, one of my projects, that we try to, let's say, make a community of users. Let's say 1,000 residential customers with PV, okay? And we aggregate them as one community, and that community decide to maximize a price for themselves. And we try to manage schedule your water heater and neighbors and whoever that is within the community in a way that you get your flexibility and also everybody get the lower price, okay?
This is a co-op, sort of.
Yeah, this is a co-op sort of, yeah. The idea is the demand response will be very, very important when we have renewable energy, and the cooperation of the customers. Customers are part of the solution.
Right.
And they will be part of the solution. Other than that, everybody needs to pay very high price. Why we have a flat price? Because in some places we have high insurance premiums to keep the price flat, or a utility that works really hard to keep it flat because to deal with all of these variations. But if the customers add flexibility, and then if the system becomes more smarter, we have all the communication infrastructure, we have intelligent algorithms available, we have people that write good games, good apps. So then everybody can be a part of the solution to try to write the better optimization code for you. Write down a better devices like communication within your home, let's say, that communicates with the Wi-Fi and turn on and off your water heater.
Now, who would pay for this? Does this get passed on to the ratepayer through the utility, or is it something that customers would have to invest in?
There is no infrastructure today in order to deal with that one. So we have, let's say you have a device that can measure a smart device that can measure your power consumption, okay? And everyone's can report it. So there are ways of using this. The first way is, okay, you have a time of use. So your electricity price is low for you between 10 a.m. to 2 p.m., for example, because we have lots of sun. So that's one way to use it. The more advanced is, well, we predict the utility or somebody predicts the sun, to predict the wind, and based on that, and the penetration of renewables, say, okay, this is in the next 24 hours, this is the price for tomorrow. Then I adapt myself to that price.
I see, and this would bring in actually the weather predictors.
This brings weather predictors, this brings system operators, this brings the battery companies, this brings the whole society to the game.
And where are we in terms of the race to get this done? In Hawaii and at UH, how are we situated with regards to how this is going to eventually play out nationally? Are we in competition? Are we ahead of the game?
I think Hawaii is ahead of the game because we are the testbed of the world. I mean, we are a testbed, and we have all of this variability. We have the ambition to go to do this. So
is some of it also because we have all of the different renewable technologies in one place that can be measured in a relatively small, concentrated area?
Exactly.
Yeah.
And our model, the model of the island is smaller compared to California, compared to other places in U.S. So it's in one hand, it's much more difficult to deal with because we're so isolated. We have no backup, we have no storage, we have no base generation if you go renewables. On the other hand, we are smaller, so
and you
we
also
can be more
mentioned,
creative. We are more agile.
Yes, and you also mentioned the political will. Part of it is the 100% renewable energy by 2045
That's a good news for
mandate.
us at university.
Right.
So,
and of course our high cost of power, of electricity.
Yes.
So it makes for a perfect scenario to do this kind of research and have some wins economically, financially, right?
Exactly. So the solution, I mean, our philosophy is that any technical solution we find should be used in the society, in the near term or long term. It should impact, and it needs to have a broader impact. So reducing your electricity bill and dealing with renewable at the same time deals with the system stability and goes very, very technical if you want to solve it at the same time. And laying out the infrastructure of the market system, demand response, of residential demand response, goes to technology developers, innovative thinkers to come up with the pieces of all of these. And it needs a system layout that look at this system, look at the all pieces and try to manage them together. So that gives lots of potential to whoever doing the research, whoever is part of the solution.
Mm-hmm.
And lots of other people in the US, in Canada, in Japan, looking at Hawaii. I have a funding from National Science Foundation. I have a funding from Department of Transportation, and they are interested. Other researchers in California, very, very prestigious universities,
Mm-hmm.
good institutes, are looking for to us to see how they can help. Because if you go to the problem, it goes very deep. It goes to understanding the stochastic systems, the behavior, understanding uncertainty, managing it, filtering out, and understand the economy of it, understand the society, how society look at it, how we understand what a collective of people think together, react together.
So in a way, you're doing behavioral economics as well, because you have to anticipate people's
Part of our work
needs and decisions?
Yes, part of our work is to understand if we give you your home,
Mm-hmm.
and I give 1,000 people one home with solar panels, with loads, and I give them variable price, and I ask you, okay, optimize what you want, give to me what you want. Okay, I simulate this one, and do whatever you want to do, or ask whoever you want to write an optimization for you, or employ these codes and these codes that we have, that maximize your price, maximize
Mm-hmm.
your benefit. And then we try to understand how it works, how you react. Are you get bored or no? Okay, you see, and we give you real money. And you see, okay, wait, I save $100 a month, so I will continue this game.
Right.
So
So are you actually doing some of these scenarios with test communities?
we are designing a game. We are designing a mechanism in order to. We designed a game. We are designing a mechanism in order to engage communities to this game and understand what's their behavior. And their behavior is very, very important for us to decide. Okay, which way is the best way of dealing with this problem? So
Fascinating.
it is a very complicated problem and it's multidisciplinary, but it's very, very interesting.
Well, when we come back from our break, I'd like you
Sure.
to tell me a little more about all the people involved in some of their areas of concentration.
Oh, sure.
We'll be right back with Reza Ghorbani. Thank you.
Okay, this is ThinkTech Hawaii, and it's Wednesday. Every Wednesday is Energy Wednesday here in Hawaii, the state of clean energy. 4 to 5 p.m. every Wednesday. Come and listen to us. And just to show you what I mean, I'm going to ask Sharon to tell us more.
Come and see us every Wednesday, as Jay said. And we have people like Jim Albers from HECO here and co-host Ray Starling here every Wednesday. We not only go on Olelo and OC16, but also stream live. So please come visit us, hear about the latest in clean energy.
Okay, Jim, you've been here. You got any comment on all this?
As important as energy is in all of our lives today, this is a great forum and a great format to vet those issues. So I encourage everybody to listen in and participate.
Okay, Ray, what do you think for a close?
Well, I think this is the greatest show in the energy world here in Hawaii. You can come here every week, 1 hour, and catch the latest on what's happening and hear from the people who really know what's going on, like Jim Alberts. We appreciate your coming today.
Thank you.
Ray Starling, Sharon Moriwaki, Jim Alberts, and Jay Fidel here in Hawaii, the state of clean energy. 4 to 5
Aloha.
p.m. Wednesday. Aloha.
Aloha.
Hi, we're back at Hawaii, the state of clean energy, and I'm talking with Reza Ghorbani, Dr. Reza Ghorbani, who's heading the REDLab, Renewable Energy Design Lab at UH Manoa. And I was about to ask you, I noticed that some of the areas you're working on are ocean and kinetic energy and sustainable economics. What are some of the things that people are working on, and how many people are working with you at the lab?
Oh, I have, I have collaboration with University of North Carolina, Charlotte. I have collaboration with Johns Hopkins University on power systems. And the project is funded by National Science Foundation. They're working on a grid optimization architecture two PhD students of mine, Ehsan and Mehdi, are working on the grid optimization architecture to, as I mentioned, to understand the variability and deal with an architecture of the island grid that can deal with all of this renewable energy. I have postdocs like Volker Schwarzer and Shayan Sariri. He's a master's student at Reza Ghorbani. He's also a master. They're working on the Department of Transportation project through HNEI. I'm a PI.
The Hawaii Natural Energy
Institute.
At UH, yeah.
Dr. Rick Rochelle is the PI of the project. And we are working together with other colleagues at the Department of Electrical Engineering, Matthias Fripps and McKenna Kaufman at the urban planning at the UH to try to understand the the focus is on electric transportation, and my group is are working on the impact of the electric transportation, like fast chargers on the distribution grid. So interaction between the electricity network and the chargers.
Are you also addressing then the issue or the potential of having electric vehicles be a storage mechanism for power?
That's part of the problems that we are looking at. So also Michelangelo, he's also with Hawaiian Natural Energy Institute. He's my PhD student. He's working on this power market, electricity market, that tries to include the demand response and the market of demand response in the grid with high penetration of renewable energy. I have a small wave energy project. Currently, I have two French interns. They came to my lab from France, working on developing a wave energy device that extracts energy from the waves. So we tested that. That's a bit collaboration with the University of California at Berkeley. And also, I don't want to, there are lots of stuff going on in my lab. So
it's amazing. I don't know how you're coordinating it all. I know that HNEI established the National Marine Resource Energy Center.
Right.
Did you grow out of that, or how did REDLab develop?
When I came here, I was interested in waves. Okay, I started to work on wave energy. I interacted with Dr. Luis Vega at HNEI, and also recently with Pat Cross at HNEI. And we are working together to see how we can move forward with this concept that we have on the wave energy generation, and hopefully we can test the scale of it in the ocean. So we are working with the Mackay pier, at the Mackay pier actually, to test the one-to-one scale of our wave energy device pretty soon. And after that, hopefully, we will work on deploying a device in the Kaneohe Bay's facilities.
Now, I remember that there was a device, both an ocean thermal, I believe, at the Kaneohe Bay, and also a wave energy device. What's
I'm not sure if they have OTEC at Kaneohe
I'm sorry,
Bay.
that's on the Big Island.
Yeah, that's on the Big Island. But
right.
I'm not directly involved in that project, so I talked to people at HNEI on that. And so I think recently they're putting two wave energy devices in the ocean. One of them is there.
One I know has been there for a while, and I've
Yes.
always wondered what's happening. Is it working? Is it scaling up?
I'm not sure about that one, but wave energy is a very, very challenging area.
And what makes it so?
Because the waves are small normally, and suddenly once a year you get huge waves. So you design your wave to extract the energy, the wave energy device, to extract the energy from the small waves, but it has to survive the big waves.
Right.
So you have to design it very well that you reduce the cost of material, cost of transportation of the device, mooring, extracting the energy, improve the efficiency, and also everything is in the marine environment is challenging. It's very corrosive, and so you have to make sure everything works.
Exactly.
So you have to simplify as much as you can.
So it's going through the same kind of development process that, for example, wind turbines did to withstand our
Right.
weather. And where is it in its development stage relative to, say, the wind turbines?
We still need time. Department of Energy put some funding recently on wave energy, but I think we need to put more to really push it.
Are there other countries that are in this race as well?
Europe was very interested. Japan was interested. Korea, I've heard.
Do they have projects in the water?
They had projects, yes. One Irish company, Ocean Energy, is coming to deploy their device in Hawaii. Yes, pretty soon. I think in a year.
And it's been deployed off the coast of Ireland?
Yes, yes.
Interesting.
So.
But they're all at the developmental stage. None of them are commercially available?
There are pre-commercial or pilot plant, yeah. The commercial, we are close. I can say we can meet wave energy meets 2045
The goal.
goal. Yeah,
Fabulous.
we will have wave energy.
Can I quote you on that and remind you if I'm
Yes,
still alive?
yes. I'm pretty sure we will have some wave energy. So definitely.
That's very exciting. And where is the greatest opportunity for a wave energy device in Hawaii?
We have lots of resources. We have warm waters, we have good waves, we have technology here in the island, the facilities is here, so we can develop the technology.
So there's no one particular area, one island or several islands that you're looking at to deploy the technology?
Oh, anywhere you have good waves, you can put.
Okay.
So
we're definitely going to see it out at Waimea Bay on the North Shore.
Well,
is
you
that
want
too
to you want to keep it away from the surf. so basically, the wave energy converters they put them very close to the shore or offshore.
Out beyond the breaking
Out beyond the
zones.
breaking
Okay.
zones. Yes.
Yeah, and I know that you also talked about some sustainable energy production in general. What are some of the other technologies you're looking at besides the ones we've discussed?
One is sustainability, as you're the expert, is a multifaceted. So one we're looking is combining the agriculture and solar. So how do you have a hydroponic, aquaponic, or organic farming with lots of solar, with shaded with solar panels? How do you design more? Use more sustainable material in your devices.
Are you looking at waste stream at all and wastewater systems, and particularly on agricultural sites?
I'm not looking at that, but there are experts at the University of Hawaii that they're looking at it.
But that's not within the purview of the REDLab?
No.
Okay.
No.
Yeah.
So we cannot really expand. It's very expensive.
How long have you been in operation?
So I joined UH in 2008, and then I started the REDLab, so since 2008.
And have you brought all of the different participants in the REDLab here with their research and their funding, or was there some funding here and you were able to?
It's challenging
corral it?
because you bring the funding, and now for your funding, let's say you secure funding with National Science Foundation, you secure funding with Department of Energy, then you have to hire good people to do the work because they're very competitive funding. So then we start to hire people to bring very good people here in the lab to make sure that they can do the job.
Right.
And not only that, they are interested, they're passionate. They stay long hours, they work, and they come with good results, and they expand. So and they spin off.
Do you have any Department of Defense funding? Because I know HNEI has pretty much a monopoly on that funding at the UH.
Well,
energy.
you should talk to Dr. Rochelle about that. But no, I usually submit my proposals to the Department of Energy, Transportation, and National Science Foundation.
And are they particularly supportive of REDLab because you're focusing on this? Or are they spreading their money across the United States?
Oh, it's very competitive. So they announce, and then we submit our proposal. We come with an idea, we come with the problem, and we submit our proposal. And then they ask for reviewers. Reviewers go there and in a panel, and they decide, they write the proposals, and they give the funding to 5% of those applicants. So let's say a National Science Foundation is, in my field, the acceptance rate is between 3%, it depends on the field, 3% to 7%.
My goodness.
It's very, very competitive.
Well, congratulations.
Oh, thank you. Yeah, we have to compete nationally.
Right.
Yeah.
Well, that's wonderful to hear that you're doing so well, and particularly on behalf of all of us.
Oh, thank you.
I'm wondering how much you're interacting, integrating your program with the utility, and do you get involved in any of their
Yes.
planning, or do they come and hang out and look over your shoulder?
I talk to them and I pursue them as much as I can. So let's say for this grants that we have, prior to that, I talked to people at HECO, and we discussed the idea together. We came up with reasonable solutions, and then we put the proposal together. So
they've been an active partner.
Yes, yes. And also recently I started to talk more with HECO to see how we can use whatever we are developing in our lab to solve part of their problems. And it has been really positive. So we are in the follow-up stage. Hopefully.
That's wonderful.
Hopefully.
Now, how do you think that relationship might be impacted with the potential takeover by NextEra? Do you think that would change, or do you feel that there's enough of a consistency that it will carry over?
That's a sensitive subject. So it depends how a company looks at the problems. So I think I have no preferences except that it must meet the requirements and the will of the people in the community. So if the community needs, okay, we want more distributed PV, we want more technology, homegrown technology, we want more innovation in Hawaii, we want to be part of the solution, it's a great opportunity for us, then HECO or anybody else needs to listen to them and say, okay, yes.
And that relationship and that openness is particularly important for the success of your lab, because you are focusing, as we mentioned, on the nexus between the technology, the mechanical solutions, the software solutions, and the communications with the customer and the utility.
Sustainability of my lab depends of the amount of good problems that we will have in front of us.
And the relationship and openness for everyone to work on that.
Yes.
Well, I applaud you on the work you're doing, and I'm particularly excited. I hope you'll come back and give us an update, because this is the cutting edge for us.
It's really my pleasure.
And I hope you're very successful as you continue forward, and also getting more funding for the REDLab from all your different resources. Thank you for joining us.
You're hopeful. Thank you.
And that's it for Hawaii, the State of Clean Energy. Mahalo for joining us.